Welcome to TechPacks, your partner in advanced research and development. In this video, we will be presenting the details about one of the most demanding research projects titled Malware Classification using Deep Learning Approaches. This research project can be extended further to publish a research paper in a reputed journal or used for your PhD or MTech thesis. So, if you are a researcher, PhD, or MTech research scholar working on a similar research project and need expert guidance to handle the complexities of research in this field, you're in the right place. Watch this video till the end to gain valuable insights into the project's objectives, methodology, and results. We'll also provide a demo of the code in action, showcasing its key features and functionalities. So, let's begin. Our professional researcher will now take the lead and guide you through the details. Here we go.
Friends, welcome to TechPacks Research and Innovation Services. Today I am here to present you one of the applications that we have designed for malware detection using the artificial intelligence. So before starting this video, let's talk about that what exactly we will cover in this particular video. In this video, we will initially discuss about in which application areas this application can be used. Then we will discuss about what exactly the code is and how we need to execute it, what are the software requirements for it. Parallelly, we will discuss about what we have implemented, what exactly the approach is, and the current problems in the existing systems. Finally, after the simulations, whatever the results will be there, we will discuss about that and what are the findings. We will give an overview to it. So let's start with the application areas. As malware detection, it is related to the security. So it is pretty much useful in the cybersecurity, network security, social media related applications where the security is important, even the industrial applications where PCs or computers or laptops can be used by the threat or the malware in order to get the data. So to avoid that, this application will be very useful. So here we are doing the malware detection on the images based, like you can see the dataset that we are using in our application is blended malware image dataset. So this dataset is having basically 31 type of malwares. Here you can see the data. So this is related to auto run related images, fake rain, and many other types of malware. Those can be there in the systems. So you can get this dataset from the Kaggle, right? So let's talk about the base paper that we are following. So here you can see the paper that we are following is from the 2023, and it is basically the analysis of the deep learning classifiers for detecting the malware images. So they have used three different classifiers. Those are CNN, CapNet. Let's see in the end that what they have done. They have just selected the dataset and trained the different classifiers in order to get the outputs. So the dataset, the classifiers that they have used are specifically in the result section. Let's talk about that. It is, so here is the custom CNN, CapsNet, VGG16, RSNet, Inception V3, and Ensemble model. So accuracy, precision, recall, and F1 scores are calculated by them. So let's see how the code is to be executed. So the folder that we are going to give you, that will have the code folder under which the final code updated has this Python file. Along with that, we do have these two folders under which there are number of malware images for the different categories. So same for the validation, because we need to validate whether our system is getting better trained or not. So to run this code, you just need to have the Python in your system. So Python must be 3.10 or above. Along with that, you need one IDE like Jupyter, Visual Studio, or any other. So here we are using the Visual Studio. So you just need to open it in the Visual Studio. So as you can see, I have already opened it. Make sure the code should be opened here. So all these libraries must be installed in your system, including TensorFlow, skimage, NumPy, Matplotlib, OpenCV, Pandas, Keras, and sklearn. So what exactly we have done in this particular application. As I already told, the previous system is just taking the dataset and identifying the different deep learning classifiers. In this proposed method, we have designed one decomposition training classification model, in which initially whatever the dataset we are using, we are decomposing it. For decomposing, initially we create the train data generator by categorically getting the training data from the folder. Here you can see the folder train. So train and validation data is used in order to get the decomposed data. So you can see when the code was run, you just need to run the code by clicking here, or you can directly run all command here. So it is showing that initially the data set was having total of this much of images, and after the decomposition the classes are reduced to this and this. So these are the count of the images, those get reduced after the decomposition, but the classes remain same. Then the data is visualized in terms to show that what exactly the kind of images for the different classes, and then we have labeled the data. After labeling, we also showed that for each category how many images are there in the data set that we are following. So further to this, the data is also shown with the count. And then in the proposed method where the training is to be done, what we have done, we have created a model in which firstly backbone model is used as VGG16, which is extracting the feature. Later on, for the classification layer, we have used the global averaging layer and the dense layer for the classification. So that's why the proposed network is called as decomposition, which is for reducing the features. Then training, where we are getting the feature from the VGG16, and finally the classification, which is done after when this network is trained. So backbone model used for it is VGG16, under which the weights are used for the ImageNet, and for the classification additional layers are added to it. So finally the training is conducted by knowing the overall information that what exactly the optimizer will be, what will be the metrics used for the training. So after the training purpose, once the training is done, the results are shown in terms of training loss and validation loss, along with training accuracy and the validation accuracy. So these are the outcomes when the data was given to it through the backbone VGG16 to train the network, and finally whatever the history is created during the training, it is shown in the graphically. For final results, we have done the testing by doing the evaluation purpose, where we got the results in terms of accuracy, precision, recall, F1 score, sensitivity and specificity, and compared with the existing algorithm. So this is the confusion matrix that is achieved for all the 25 classes. And finally the comparison is done with the values achieved from the paper directly. So here you can get the values, and it is shown here graphically. So you can see in every parameter, either it is accuracy, precision, recall, F1 score, the curve for the proposed algorithm is higher, which shows the effectiveness of the proposed model. So further modifications are still possible, and for the research thing, this can be extended also. So I hope you people like this video. For any kind of information, feel free to contact us directly to know more about the decomposition, training and classification based network which is designed here. Thanks for watching the video.
Thank you for watching this video. We hope you found it informative and engaging. For more information about this research project and to get our consultancy services, click the link in the description below. At TechPax, we offer comprehensive support for researchers, PhD, and MTech students in the fields of engineering and ICT. Our services include selection of research topic, helping you choose the right topic tailored to your interests and the latest trends. Synopsis preparation, crafting a clear and concise synopsis with well-defined objectives. Coding assistance, providing expert help with writing and optimizing code in various tools and platforms. Research paper writing, assisting in drafting and editing research papers to meet the highest academic standards. Dissertation writing, offering complete support for your dissertation, ensuring consistency and quality. Plagiarism check and removal, ensuring your work is original and free from plagiarism with advanced detection tools. We also offer customization services to meet your specific project needs. Whether you require a modification of an existing project or a completely new application, our team of experts is here to help. Don't forget to like, share, and subscribe to our channel for more updates on cutting-edge research projects and expert advice. Thank you for choosing TechPacks. We look forward to collaborating with you on your research journey.